Welcome back to my channel. I'm Brian Kafke, and this is Lesson 10, Advanced SQLite Features in the series Python and SQL. Drinking out of my Star Trek mug today and wearing my new Star Trek hat. Let's jump in. So where are we going? We're going to do a very quick overview of the SQLite architecture, followed by reviewing SQLDF, which we're going to use intrinsically in this video. Especially when we get to the demo, I'm going to be using that as a way to simplify our data load. We'll also be using SQLite advanced features, so I'll be demonstrating that in the code review. So the SQLite architecture starts in a very simple place with a file. SQLite just stores all of its tables, views, and objects in a simple flat file. And it's very similar in that way to, say, Microsoft Access, which does the same thing, except it's only got database objects. It doesn't have all the other stuff that Access stores, like forms, etc. So in that file, you would store your tables as shown here. And the way you get in and write and read to it is with just the SQLite 3 module. That's it. Doesn't have a service. It's not doing this whole back-end thing that you might be used to in an enterprise database like SQL Server. It's just using libraries that are running right in your Python program to read and write objects in the SQLite database. Now, I do want to caution you, this does not have security features. So when you use enterprise level security databases, you have a lot of security features and grants and permissions, and you have this dedicated server typically that will stop anyone from getting in that shouldn't. SQLite, it's just a file, so it's as good as you've protected the file in a folder or something. There is no grant, there's no protections that way. So don't put anything in the data, in the file, that you don't feel comfortable putting there. If it's sensitive, don't put it there, or at least secure that file to the level you think is necessary based on how worried you are about the data. But to the extent you can share the data, the nice thing is you can send it, you can give it to people, and anyone that has Python, or pretty much any other language, will be able to read and write and use that SQL database. So when we talk about what I really want to demonstrate here is building a professional data warehouse using SQLite. So we're going to build it right in SQLite. And when I say data warehouse, it's really just a base. It's where you're going to be doing your data analysis work. I'm going to demonstrate something that's more or less a dimensionally modeled data warehouse, but it could just be your staging data. You're doing analysis and you want to save tables, etc. You can follow the same ideas and principles I'll use here, whether you need all of them. So let me talk about what do I mean. A really key principle is parsimony. Take only the columns you need, only the data you need from whatever source. So if it's coming from a relational database somewhere else, don't just grab the entire tables and columns. Take what you need, filter it. Only columns you need. You don't need maybe 500 columns, you only need 50, take the 50. So that's the first thing, only what you need. Add indexes to improve performance. That's one of the benefits of having a relational database. SQLite supports that. So adding indexes means that you'll be able to read data in and filter out just what you want. You'll be able to easily join things, and it'll be efficient and fast because the index will speed things up. So that's a key thing as well. Implement referential integrity. Referential integrity is when you define the relationships between the tables. So in our case, we're going to have the fact internet sales table, which has, for instance, the key to the product table, product key. And by defining that the product key is a foreign key that points to the primary product key on the product table, SQLite can enforce that relationship as well as optimize joins and things around it. You can also have calculated columns, default values, and constraints. And we'll see some of this as I go forward. The other thing that I want to do in this particular example is denormalize tables, which means get rid of too many tables. In this case, we're going to consolidate the product tables because it's snowflaked and we don't want to keep snowflakes. So there are 3 easy steps, and I want to sort of emphasize that this is something that took me a really long time to figure out the easiest way to do this. What I mean by that is I don't want to have to do too much, insert statements and looping over rows. And a lot of examples I see on the internet or even in other videos on YouTube get into a lot more work than I like to do. The key to doing this with minimal effort, and which also means better basically less bugs is by using the tools that are already there that have been tested to do this well. So the tools I like to use is Pandas, and I'm going to use something called SQLDF, which we talked about in video 1 of this series. I'm going to post that link in there so you can go back and refresh your memory if you like. And let's jump in. So we have this program here, Python code, and the first step is wherever the data is, whether it's in another relational database or it's in a JSON file or CSV, Pandas is really an awesome library for reading data and writing data. It's really, to me, become the hub of data analysis. So what does that mean? It means that the easiest thing to do is whatever you're going to do, get it into a data frame. So that's the first step we're going to do. And once we have our data in a data frame, and data frames are really like in-memory tables, or think of them like a spreadsheet of rows and columns of data. Once we have it, we're going to use the function SQLDF, which allows us to use the SQL language, structured query language, to query data frames. We're not going to be, when we do this, I don't want to confuse you because it's easy to think, oh, now we're dealing with tables. But we're actually not. We're just using SQLDF as a way to pull the data out of the data frame we want to load into our SQLite permanent database. Now, interestingly, I don't know if I covered this too much in the first video, but when you use SQLDF, under the covers, it actually does create a SQLite in-memory temporary database. So when you do a select on a data frame, it automatically detects that data frame and will push it into a SQLite database and then queries it and does what you want with SQL. That's how it generates its SQL support. But we don't need to know that really. I just pointed out we want to leverage the ability to use SQL to simplify our data warehouse work here. Once we get it through, and remember when SQLite queries something, it returns a data frame, which is really nice because by default SQLite functions don't return data frames. They return lists and things like that. So it's not that easy to really work with it. But SQLDF automatically returns data frames and it's integrated with Pandas. So we're going to take that feature and we're going to use it so that we can create and persist our SQLite database. Unfortunately, Pandas has the ability to write to many formats, and one of them is SQL databases. So we're going to take advantage of that. So that's the overall approach. This is our notebook. I will put a link in the description which has the code and slides, so you can go in here. It's a Jupyter notebook. I'm using Jupyter Lab because I like Jupyter Lab. It's got a few extra features and it comes with Anaconda distribution. I have another video for that as well. There's some things I'm putting at the notes, quirks of SQLite. I'm not going to really stop and pause on those right now, but also advanced features, some of which we've talked about. We'll use some of these features like foreign keys and things, and some we may not use right now, but take a look at these. One in particular I won't use is triggers. Triggers are, to me, a bit of an edge case. They're useful in application tables. I don't think they fit very well into an analysis project, but if you have the use of them, those are things that can run code when somebody inserts or updates data on the table. So we're going to start right here, importing the SQLite 3 library, which is right here, and then we'll just print out the version. So I have version 3.32.3, which is a couple of years out of date. That's okay. I have what I need, and you can go and get the latest, greatest. If you're slightly behind that, I think you'll be okay. The other thing I'm going to do, I mentioned I want to use SQLDF. Now, SQLDF comes from Pandas SQL. If you don't know how to install it, you don't have it, you want to use it, again, the link will be in the description to go back to the first video in the series, which talks about using Pandas SQL. So go back to that and have fun with that. That's the easiest way, I call it the easiest way to use SQL with Python. And we're creating a little function here because the SQLDF function requires a parameter which has to do with the environment variables that it's going to have access to, the scope. It supports locals and globals. That really doesn't matter in our notebook, but since we've got to keep passing it, I'm going to say this is a common thing done. I'm going to create a little function that automatically hard codes it to always just use global, so I don't have to keep passing that in. Less code is a good thing. All right. Now what I'm going to do here is I'm going to use SQLite 3. That's my library, right? And I'm going to use the connect method to create my database or connect to it. I'm using, this is the file name. If the file doesn't exist, SQLite automatically creates an empty file and you're good to go. If it does exist, it opens it up and it's ready to read and write to access the objects in the database. this is going to return a connection object. So let's take a look at that. And I'm doing Shift Enter to run the cell, and then here, and it just shows me that by printing this out, it's a connection object. That's all I really see. Now to send statements to the database, to SQLite, I actually need to use what's called a cursor. The cursor is not the typical cursor if you've used them in like SQL Server, other databases like Oracle. Typically a cursor in those environments is you do a query and you get a result set back, and the cursor is an imaginary placeholder that you use to step through the result set. That's not really what a cursor is doing here. I'm not really fond of the term because they use that and it's a bit confusing. A cursor here is really more, think of it like a prompt in which you enter statements and that statement will then be executed by the database or by SQLite. So we're going to use cursors when we want to send SQL statements over to SQLite to do things. So we're going to create our cursor object, which is, if you'll notice, is a sub-object of the connection, and that's going to get returned to cursor. There it is. I've already talked about the strategy, and we'll walk through that, so I'm not going to take any more time on that. The only thing here I want to show you is the center of our warehouse. This is our schema. We're using AdventureWorks. It's safe data. It's demonstration data that Microsoft creates. Fact Internet Sales is our fact table. Fact tables in a dimensionally modeled data warehouse, which is what we'll be doing here, and we're using a data warehouse that Microsoft provides, is our metrics only. So these are measurements. The idea of a dimensionally modeled warehouse, and I will put a link to my riveting video on that, is that facts only hold metrics and pointers to other tables which store descriptive information about the metric. So if you have a sale, the metrics are how much did you sell, how many units did you sell, maybe the tax amount, maybe some other number. Everything else, what product did you sell, that describes it, right? So that's a dimension. When did you sell it? That would be a date dimension. Who bought it? That's a customer dimension. And again, on, and those are all dimensions. So we're going to see how we can lay that out. There will be keys to connect the fact internet sales table to these dimensions, and we can make them foreign keys, which implements referential integrity in SQLite. Now, I've noticed playing with it, SQLite's not terribly tight about enforcing things, including the constraints around referential integrity, but it should at least enforce, it will create indexes for you to increase your performance, and you can experiment about how much it will keep you from deleting things that it shouldn't. But that's the idea behind referential integrity. I'm going to take the three tables, product product subcategory, and dim product category, and just squish them together into a single dimension, which would be, I think, a best practice for this type of situation. When a dimension points to another dimension, has a relationship, it's called snowflaking, and it's a bad practice. So it's unfortunate that there's a popular data warehouse product out there called Snowflake, because it's actually a really bad practice to do that in data warehouses. All right, now that we have that down, we're going to be using pandas. And again, I use pandas as much as I can whenever I do work with data, because it just makes my life easier. So I'm importing pandas, and I'm going to use this prefix PD when I want to use pandas functions. Here I'm doing PD, and I'm using the read CSV function, which is a really great function. It allows me to read in CSVs. It automatically, if the first row in the file has the column names, it will automatically create those as the data frame column names. So it makes my life easier. The period / says, starting from the current folder where I am, look to the subfolder, in this case data, and find this file. It is case sensitive in terms of the file name, so make sure when you do this, you spell things right. Now I'm going to load that and return it into this data frame, but now I want to filter the data frame. I may not want to load everything, so I want to demonstrate to you that you don't have to load the entire data frame. I'm going to data frame filter. This is standard pandas formats. There's several ways we could do this, but here what I'm doing is I'm data frame, and then I'm putting a subscript more or less in, which is the filter criteria. DF date key, the column, is greater than 2011-12/31, which is obviously the last day of 2011. In other words, I want to get all the dates after 2012, starting in 2012. And I'm going to return that and replace the data frame I started with back to DF date. And just the next statement here, I press Shift Enter to this as well, and you can see, yep, it worked. We got what we want. Great. Now you'll see that we have, like, that's kind of a long name to deal with. We may not even want the alternate key, but in this case, it's just a nice date format the way you typically would display it. We've got a lot of columns in this particular warehouse where it has English, Spanish, French names for things. If you're only going to use English, which is what I'm going to focus on, then you can just rename it and get rid of the other columns. You don't have to carry those along, and it saves you space and time. So we'll see that as we go along. Now I mentioned, and I want to be very careful about this, we have this data frame, DF date. We have not saved it in SQLite. Really, honest. We've only got a data frame. We can see that we used the head method of the data frame to print a couple of rows. So we really don't have a table yet. However, we can use a select statement and treat DF date, really highlight that there. We can treat DF date as if it were a table. And if we do that, it works great. Now remember, SQLDF is just an ease of use function we created that calls SQLDF. It just hard codes the environment parameter globals. What does this mean? Well, it means I've got the data frame, right? And I want to take the data in the data frame. Maybe I want to rename some columns. Maybe I want to pick only a few columns out of a large set of columns in the data frame, on and on. So by using the SQLDF function we have, we're going to be able to use SQL to pull data out of our data frame and then push it into a real SQL database, a SQLite. That's the idea. So we're using SQLDF really just an ease of use feature, and I think you'll find it really helps a lot. So what I'm going to do now is start my real database work here. I'm going to create a script, create_dim date. It's just a string in Python. I'm just going to hold the string. And this is a doc string, right? So it's got the triple quotes. Now I want to do two things. In case the table already exists, I don't want to get an error. So I'm going to say drop the table if it exists. And the name of the table is dim date. And if it didn't exist, then it doesn't matter. But if it did, it will drop it. And then it can run the create statement. I could, and I have in a previous video, use Pandas to automatically generate the table definitions and save it for me. But I want more control this time. I want to control column names. I want to control which columns I'm actually going to pull from a data frame, and I want to do other things. One of the things I want to do is create a primary key. I don't want to use the default row ID that's put on SQLite tables by default. This way, I'm actually telling it, I want this as the primary key, which means I will get a unique index, which will improve performance, especially when I join to it, and it improves data integrity. The rest of it I can say not null, right? So I have not null constraints. So those are nice things I can do as well. Not doing a huge amount here, but I'm also, if you'll notice, no English prefix on the names because I'm only going to be taking the English versions of it out just because it's the only language I know, right? So let me run that. And I'm going to now do cursor execute script. Now I do want to call your attention. I'm going to be running that string. And remember the cursor, that's our way of sending commands or running statements to the database. And you could normally say just execute. You may see examples of that out there. But execute can only run a single SQL statement. I want to run multiple statements, and that's basically what SQLite considers a script. So we're going to say execute script. That allows me to both do the drop and the create in a single pass. So I'm going to run that, and that's great. And then we'll come down here, and now I have my table definition. I want to extract data from the data frame and push it into the table. I'm going to use the SQLDF function right here to query the data frame and customize what I want from the data frame to push into SQLite. For instance, you can see I have the full date alternative key. I'm just going to call it date value. It's easier to type. I also have English day name of week. I'm just going to call it day name of week. And I have English month name. Going to change it to month name. In other words, make it a little bit easier to work with. Now, since this function returns a data frame, SQLDF does return a data frame. Remember I said that's one of the great things about it. I can, without even storing it in a separate data frame object, I can append the toSQL method, which is a data frame method, a Pandas data frame method, and it saves the data frame to a table, which is pretty cool. This is the name of the table. The connection, CONN, is the SQLite connection we created, so it knows where to write it. Index equal false says Data frames have indexes. It's this sequence number it puts on all your data frames. I don't need that in the database. I'm creating a primary key, so you can say index equal false and it won't create that in the table. Now here's a key thing you must remember, critical. Always listen. If exist equals append means don't drop the table and recreate it. Just insert rows into it. If I said if exists replace, which I've done in other videos, so be careful, that means drop the table and recreate it, which is okay if you want Pandas to just create the default format for the table based on the data frame. But we'll lose our primary key, we'll lose our constraints, we'll lose the control that we have. We're building a really robust data warehouse, so we're going to we've already created the table the way we want it, we're just going to insert into it. Okay. Now, we want to load sales territory. And by the way, I'm going to review these tables in a minute. I'm going to use the SQLite Studio to show you that you can browse and look at all these things. But let's get through this and continue where we're going. So I'm again, import pandas. I'm repeating the import statements on a lot of these so that the cells can run independently. Also, so it's clearer to you where these libraries, these functions are coming from. So again, I'm creating the data frame, df sales territory. The data frames I'm using are prefixed with df, so I don't confuse them, and you don't confuse those with the actual tables we're inserting. We're going to use the read CSV again, and again, it's in the sub folder data. This is called dim sales territory. So let's create our data frame. Now in this case, I'm going to be as lazy as possible. It's a small table. It's only a few columns. I'm not going to bother creating it separately. Notice I didn't run a script to create this table. I've shown this in other videos, but I wanted to demonstrate it here. I can just say PySQLDF up to here, right? That will get me a query using the df sales territory data frame. It's going to return those columns, and I can append the toSQL just as before. I'm going to call it dim sales territory, connection, index equal false. Here's the difference. Notice it says if exists equal replace. That will drop and recreate the table if it existed. Now it doesn't exist, so that's fine. Instead, it's just going to create the table for me. There won't be any primary key index created. There won't be any special constraints. That's okay. I'm going to take it the way it is, with one small exception I'll show you in a minute. Okay, so that ran. Now let's run the next statement. What I do want to have on this table, since it's going to be a foreign key to another table, it would be nice to take the sales territory key ID, okay, over here, and I want to create an index on that, on dim sales territory. So I'm going to create a unique index. I'm going to say if not exists, so I can again rerun this if I wanted, and it won't give me an error if it's already there. I'm going to call it, this is my name of my index, and it's going to be on this dim sales territory, just sales territory key. Now a couple of things you can do, and it's a great way to show you, you can do transactions, right? So real databases, DBAs will tell you to do transactions. SQLite supports begin transaction and commit. It can do rollbacks and all those things that people love and know about databases. So I'm just going to demonstrate that here. So I'm going to create that little script to create my index. And I just did it all in one pass, run that, and I embedded the statement right there, and it worked. Great. Keep going, a little bit to get through here, but we were building a complete data warehouse. I'm going to create now a geography data frame. Again, reading in this time dim geography CSV, and I'll just to show you, you can use D types as a way to just get a list of columns and data types from the data frame. So there it is. It ran it, and you can see object generally means it's a string when you're looking at a data frame. All right. Now we got a data frame, we need to load it into an actual table. So again, we're just going to create a script. The script here drops the dim geography if it exists, and we're going to create our table. Again, primary key. We've got the sales territory key. We don't want a null. We're going to do something here which is a little different. Is a really good practice when you create tables in a data warehouse is to create typically two columns. I'm only using one, but typically two. One is the date added, which I typically call insert date. The other one is last updated date or update date, however you want to call it. When you first insert a row, it's good to say this was inserted on. And the other column, if you do updates in your ETL process, you want to also track when it was updated. So the ETL should normally do a zap on that column and say this is when it got updated. And that can be done in the code. Fortunately, when it's inserted, you don't actually have to load a value because you can just make it default. So I'm going to say this is a timestamp. It can't be null, and I want it to be defaulted to the current timestamp, the current date time as is. That's great. So that means that when I go back and I'm wondering about data in the warehouse, I'm like, this data looks weird. It seems wrong. Is it right? Well, maybe I look back and I realize like, oh, that data it was inserted, just last month. It was a new insert. This is showing I got it a year ago. Like, what's up? So the idea of these insert date, update date times, and very often you don't actually put date time, but you can name it however you want. But the idea there is that it's good for debugging and traceability. Really good practice. I recommend people do that. I try to do it on any warehouses. A little extra overhead, I know, in the database, but you need to have frameworks and traceability around your data in any kind of ETL process. So I'm going to save that script to do that, to build it. And by the way, notice we're creating a foreign key constraint. So we are saying that in this dim geography table, there's a key, sales territory key, which references dim sales territory of the same name, and that's a primary key in that other table. So it's going to enhance our ability to maintain our model and join between the tables. So let's execute that code. And one of the things I have now, I created my table and I want to do something. I want to take this data frame we created, DF geography. It's got more columns than I want. And again, I have this English prefix, which I find to be kind of a pain. So I'm just going to use good old SQLDF again, the SQLDF function, to pull off the columns I want, and also I can rename one like this. Now I don't have to use SQLDF, but I find it really natural since I'm building a SQL database to use SQLDF to do it. It's kind of like keeps my mind in one place. But if you really love pandas and you want to do it with pandas, you don't have to use it this way. But I think it's cool. And so this is going to return the result of that query, which is a subset of SQLDF. Subset in the sense that it's only some of the columns. And I can confirm that just by taking a look here, by using the head function on the data frame. And again, there it is. Now in this case, I'm going to take that data frame now. Before I was running it all in one sort of big cluster. But here I'm going to take the data frame. I don't need to do the query anymore. I'm just going to say to SQL. That method will write it to this table. Again, connection, index, again, what we've seen. And if exists, equal append. Why do we say append? Again, we don't want it to drop and recreate the table. We say replace, it will drop and recreate the table. So I'm going to run this statement. And now I'm just going to kind of step through quickly, grabbing the 3 product tables that I want to consolidate. And I'm going to print one little row out for each one because it just makes me feel warm and fuzzy to see each data frame really got created and I have data in them. Okay, so we can see it did all of these. And I'm not going to worry too much. There's nothing new here to see. So let's jump forward. I'm going to create a SQL query here. And the idea here is I've got 3 data frames. I'm going to use, again, SQLDF. What I want to do is join the 3 data frames and only pull up the columns I really need and simplify it into one table instead of 3. So I'm going to be joining from DF product, which is the data frame I created for that. I'm going to inner join it with DF product category. And I'm going to also inner join that with subcategory, and then I'm going to connect that to category. And you can see I've got the join keys. Now technically nulls are allowed in this table set, this database between these tables. So it's a little weird sometimes. I'm not sure why it allows that, but I'm going to use inner joins. If you were really doing this in real life, make sure you use the appropriate join. But typically, I recommend if you have a product and you've got subcategories, you should always reference it. It should be there always. Anyway, let me store my query. Now I'm going to run the query just to test it, that it does what I want. And you can see I've got a nice, simple set of columns. Not only is it not 3 tables, but it's only a handful of columns that I have to deal with. I want to put that data set into DF product subset by running SQLDF and that SQL statement. That's what I'm doing there. And now that's great. I got it. I need a table to store it in. So I'm going to execute drop table if it exists. I just wanted to show you if I don't want to execute script, I can do execute, but I can only do one statement at a time. So the first statement will drop the dim product table if it exists. And the next statement is going to create my table. Not a lot here, primary key, and again, the insert date timestamp. And I kind of forgot to take these brackets off, but it's good because those are syntax that SQL Server understands, which gives me a moment to point out something. SQLite understands the data types of just about every database you can think of, at least the big ones, Oracle, SQL Server, Postgres. And that means that you could take most create table statements from, say, SQL Server, and I do this later on, and just paste it into SQLite, and it will probably work without a change. At least the data types will. So you might say varchar 5. Well, SQLite's going to understand it, and it will translate that for you automatically to just being a text column. SQLite doesn't have a lot of subtypes like some of the other databases, but it automatically maps to them and it works. So kudos for them for doing that, because it really makes life easier. All right, so let me create my script to hold this, or my execute statement, and now I can just execute that single statement that creates a table. All right, so again, not execute script, just execute, since it's only one line. Okay, now I'm going to take that, now that I've done that, and I've already created my DF product subset, I'm going to, that data frame has what I want. I'm going to do toSQL on it, dim product, and all the stuff we have. And again, append, because I've already created the table and I don't want to lose those wonderful attributes I created. And just here, this is, I like to show, like, I'm always curious, like, what's the metadata? How does it look? I can query, I showed you D types, but I can also use columns, and it just gives me a list back of what are the column names in that data frame. Now, another way I can query metadata is using SQLite. There's a schema called information_schema in, I think it's a SQL standard, and so in SQL Server, Oracle, etc., we typically have that, and you can query different views from that schema. SQLite takes a shortcut to this. It's not SQL standard, but it works. They store it in a table called SQLite master. So when you want to find out what tables do I have, what objects, what indexes, etc., you can look there. And this is another advantage over having just a bunch of CSV and JSON files in a folder. You've got a place where you can look at it and actually see what are your objects and what are they indexed like, and get information about them. So one way to do that, again, I use Pandas for everything, because I like to get things back as a data frame, so I can just do read SQL query from SQLite master, and where the name is dim product. So we're going to get information about the dim product table. We can see it's a table, there it is, and you can even see this is the SQL that was used to create it. So pretty cool. So we can query SQLite master for tables, columns, etc., and that's a pretty natural way for me, I think, to work with querying objects, because that's typically the way you would do that in other databases. But SQLite has another way of doing this also, where you use something called a pragma. Now, here we have a pragma, and one of them is, say, table info. So let's run that just to show you what it does. And again, we're passing in the connection object, and I'm using it as a query just like the other thing. So I'm still using pandas, but it's not a standard SQL statement. The pragmas work well too. This gives us another way of querying information about tables, columns, indexes, etc. So you can use either one. Because pragmas are not SQL standard and they're unique to SQLite, I find the other method a little bit easier, but I do go back interchangeably depending on what I'm doing. Okay, finally, we've loaded our SQLite table. Let's take a look at how it looks. Okay, now this doesn't say DF product, so that's the slight subtle difference, which means I'm really querying SQLite. You can also tell because I'm using read SQL query, which I wouldn't use if I was using SQLDF, and I'm also passing in the SQLite connection object, and it just shows you that I have the product key, category, subcategory, all that stuff. Very small subset of columns, but I can get what I need for product information. Now the final one, this is a more robust example of loading a table, the fact table. Fact tables are usually, because that's at the grain of your data, the level of detail, could be sales order items, it could be aggregated to say invoice header or something at that level. So this table is typically the one that's the most important in any data warehouse. Now I've got some information here about auto increment. Auto increment columns are a little strange and misleading. SQLite supports auto increment, but then tells you don't use them. The reason it tells you not to use them is because it will automatically implement something similar to an identity column or sequence in Oracle, and you don't need to explicitly tell it to. Now let me walk through this a bit. I'm going to first drop the table as we've been doing, then create my factor internet sales table, and I'm replacing the primary key. Now there's a difference between what I'm doing here and what I've done in the past, and the difference is this. I don't intend to tell SQLite what the primary key is. I want it to generate, similar to a Microsoft SQL Server identity column, I want it to just generate 1, 2, 3 and keep going. If I put, and actually force it to say auto increment, it does a thing where it makes sure that you never reuse keys, and it does extra work to enforce this kind of thing, which is typically not needed. So again, the information's above, there's a link above if you want to look at that, but generally you want to just tell it that you have an integer, it can't be null, and it's your primary key, and SQLite will automatically maintain it for you. You don't have to do anything more. Isn't that great? And also notice I got a lot of not nulls here. Now here's a really key thing also. I didn't want to have to type all this in by hand, so I went to the SQL Server Management Studio and I generated, you can go through and just pull out the create statement for a given table, and I did that for fact internet sales, and then I just deleted the stuff I didn't want. And for that reason, you see ints and brackets around things. Notice the brackets, the int, small int. Small int is not even a type in SQLite. You have floats, money, which is a weird one I don't even use typically in SQL Server. You have date times and real. So all these things, the nice thing is SQLite understands it, and I don't have to retype everything into SQLite syntax. I can put a check constraint. So this says only allow this to get load if the sales amount is greater than or equal to 0. So I don't have negative sales. That would be kind of strange. I can default my tax rate to 0. So I'm going to have this. If nothing's 0, I'll default it to 0. Profit margin is null, so that allows nulls. And then I have a couple of foreign key constraints. So I'm doing quite a bit here. And again, I defaulted insert timestamp. So Shift Enter will run that. And then I can run this to create my table. And there it is. Now I've created my table. We've done a lot. We haven't loaded it with any data. I put a file out in the zip that's up there on GitHub, which is a subset of fact internet sales, because fact internet sales is actually kind of big. So I reduced it just to 2014. And I'm going to show you, we're going to load it here. And you can see the shape method here tells us there's 1970 rows, 1970 rows, and 26 columns. And we can see that we've got our data frame loaded. So now we're good to go. So we're going to create a script here, or a SQL query that has what we need. So it's pretty much just listing what are the columns we want to take out of DF internet sales, the subset of the columns. What do we really want? Where we could have, and I didn't show this, but we could have in the table definition defined calculated columns with this formula that I'm showing you here, but I'd rather do it in the SQL statement. It gives me more flexibility, because if I want to change it, I don't have to drop the table. I can just change it, truncate, load, whatever I want to do. So I'm basically just saying tax amount divided by sales amount is going to be the tax rate. So I'm just calculating a tax rate. Now, a lot of times when SQLite does this, it gives you way too many decimal points or decimal values. So by using the round comma 2, I'll only get 2 decimal places, and I'm going to call it tax rate. I'm going to do the same thing here. It's sales amount minus total product cost, which would be basically the sort of gross profit, divided by the sales amount is going to give me my profit margin, and I'm going to round that to 2 decimal places as well. So let me run this cell, and I'm going to run PySQLDF, running that query above, just to see how it looks. I'm not using it yet to load the data, but I'd like to sanity check what I'm doing, and it looks pretty good, right? I got all my columns here, my shipping date. You can see tax rate, profit margin, looks good. All right. Now I can take that same query, PySQLDF, noticed again, but this time I'm going to use the toSQL method and do what we did again before. And again, we're going to use append because we don't want it to drop the table and lose our wonderful attributes. That's it in a nutshell. And just to kind of go through, okay, well, did it work? I do want to quickly show you, like, why would I do this, Brian? Why do I care? So one of the things I can do now is I can use SQLite as my base for my analysis. I really like this because I can clean things up and get different persisted tables that says this is really clean, and use it over and over again, and I don't have to keep reloading things from CSV files. And remember, because we have indexes, it's really efficient to bring in subsets, whereas a CSV you have to load the whole thing more or less, unless you use extra features. In SQL, I can just say, give me only 1 year of data, and it will just automatically give it to me. So there's a lot more flexibility. So again, importing SQLite 3 and Pandas, I'm going to do a SQL statement here, and I'm just going to be doing like a summary. And notice I'm doing a join, etc., and grouping, and I'm aggregating sales amount. And what I get here, just to show you how it's kind of cool and what you can do, I'm getting a total sales by category, subcategory, and product, which is kind of handy. You might use that. Now I could make a view out of that, etc. In fact, I'm going to show you how to do something like that here. I can say drop this view, and I'm going to create a new view. A view is really just a named query, but it has the cool advantage of being able to be treated in every way like a table. What do I mean? I can sort it. I can do groupings and sums and just use the view name as if it's a table, but it's not actually a table. So you might ask, well, why don't I just use a table? Good question. One reason is that if your data on the back end, if you're what they call base tables, the data we've been loading, maybe it keeps changing every day and you keep reloading new data or extending it. Well, you don't want to necessarily have to keep loading all these other copies of that table in other places. It's going to become unruly, and you'll never know, do I have the latest data? By using views, you can run them against the greatest, gold copy source of data, and you'll always get the latest version. And as long as the overhead is not intense, they come back pretty quick, and so you kind of get the best of both worlds. So I'm going to create a view here, which is this statement here. It does this information. It's pulling out order dates and things. It's getting stuff from product and dim date. Let's run it, and I'll run it here. So this is going to run that statement to create my view. And let's take a look at it. The name of the view is vSalesInfo, and I'm just going to pull 3 rows out. But you can see, okay, so it's brought all this data together. And notice how I can treat that view name, vSalesInfo, as if it's just a table. I can do whatever I want with it, which is pretty cool. Now I can do some other things here. I can say select here, and I can just kind of demonstrate different things. I can group by some amount and then do that in descending order. And that's just another way I can do this is giving me the sales territory country, so basically the country by region, and then the total sales amount. Now, a key thing to pay attention to is I changed the index column. This is a Pandas feature of this particular command to use, instead of the default index, I indexed it by the country, so it looks a lot better, right? It's easy to follow. And the little round at the end, without doing that round, if you've used Pandas in this particular way, particular with SQLite, you find you get extra decimal places, you can just append the round statement, and in any of those numbers, it will automatically round to that number of decimal places. All right, so we've done this, and I can now close my database cursor and connection. It's a good idea, best practice to do that. But I do want to do one other thing before I leave. I'm going to go into, I have SQLite Studio. I don't know if you saw it in the right corner here. Now I need to refresh this because it gets a little out of date. But when you want to connect to a database, you can just go in here and say add a database, and then you go here and connect to it. But we're already connected to this, so I don't need to do that. And then it will show up here as I can see here. I can see my tables are here, right? I can see my columns. A really cool thing is if I double click on a table, I get the structure. If I click on the data part of it, it will query it, and I can just look at the data. I don't even have to write any queries. So using this, the structures here, the indexes, etc., I can look at all of the DDL, the create stable statement. I can just cut and paste this. Using something like SQLite Studio is a really powerful tool to augment your analysis, because you can bounce between these. If people who've used SQL Server and use SQL Server Management Studio will attest to this. It's an awesome tool to have. And SQLite Studio is not up to that level, but it's pretty good. And I've been studying more and more on it. I probably will do a video on that just because of all the cool features. And by the way, we can see that we have a view here, etc. So it's good also if you're trying to get familiar with the database, you can't figure out what something's called, you can use this as well. And it just connects to the file and displays it. So wrapping up, as I take a swig, we did a very quick SQLite architecture one-slide review, and I hope it was riveting. The real takeaway is it's just a file, and SQLite's maintaining the tables and objects in there, and it does that just through a library. We use SQLDF as a way to simplify things. I hope you can see, I hope it made sense. I haven't seen anyone else do that anywhere. But to me, I'm like, wow, that would just make it so much easier to query what you want and stuff it into a SQLite database. And I think it did. I talked about using SQLite advanced features and really demonstrated that, I hope, in the notebook that you can go for your own use. So take a look at that. But there's quite a few good features, and I think it's really undervalued. I don't see many videos out there. In fact, this series is the most extensive series I've seen anywhere on SQLite and Python. So it's pretty cool what you can do, and there's still probably more topics I can cover. So there's a lot there. Due to my enterprise hat, or Federation hat, live long and prosper. Please comment, like, share. Let me know your thoughts about this video and if it's helping you. And remember, I'm pulling for you. We're all in this together. Thank you.